Good afternoon, everyone, and good evening to many of our partners that are contacting us from other countries. Well, all that said, I'm Marcos Matos, General Executive of Secafé, the Brazilian Coffee Exporters Council. It's a pleasure to have you here for another discussion about the carbon balance of Arabica coffee in the state of Minas Gerais. Months of dedication and the support of many of our members, and excellent work developed by Mafara under the supervision of Ado Serri from the University of São Paulo, with several stages this month, selecting properties, 40 farms, representing the production system, field work with soil analysis, plant analysis, opening trenches, removing coffee trees. So a huge work that shows that based on science, the sustainability of coffee in Brazil. And as Brazilians, we have to be proud of our science and scientists. Professor Serri is recognized by Reuters as one of the greatest scientists in the world. Professor Serri is the full professor of Exalc University of São Paulo with international prestige, and in Florida, the institute that is in charge for management and is very knowledgeable for its transparency and working with the sustainable use of soil and forests, bringing benefits to rural properties and the Brazilian community as a whole. So I recognize the work of Imaflora, Professor Serri, Silva Pizol, and our team in Secafé. And I also thank all the organizations, Silva Pizol, our team, and the work group comprising Secafé members, and together with our sponsors, Starbucks and Lavazza, all together, we were able to turn this project into concrete results. Particularly, I would like to thank Flávia Barbosa, that is the coordinator of the Sustainability Committee of Secafé, and really devoted herself to this project from scratch to execution, planning, results. So she has been paramount to us all in this period. On behalf of Flávia, we thank our president, Nicolas Coelho, that was not able to be with us because he is in a job assignment, but he left a message talking about Secafé representing Brazilian coffee growers to really show the sustainability of our coffee industry. A beautiful work developed by our growers, and to show, based on science, that we support the environment, we have diversity, and we really cherish the human side of coffee. Going on with our presentation, just in terms of context, we represent the exporters of coffee in Brazil, nationally and internationally, 120 altogether, including companies, cooperatives, and we are in charge of 90% of all green coffee that Brazil exports, 147 countries in the last 5 years. Brazil is absolutely the largest producer and the second largest consumer of the beverage. In terms of ESG, Secafé has developed strategic plans for the coming years, redefining all our strategic pillars, all of them, but focusing on two, which is communication, promotion of our image, and social responsibility and sustainability. We are gearing our efforts for projects with multiple stakeholders, paying attention to the global discussion and the new rules that are being passed worldwide, specifically in Europe. And the main focus is carbon, climate changes, the traceability that is more and more demanded in global production chains, the carbon dynamics, water dynamics, and so many topics that are really a priority in our topic, and the training of growers in a modern dynamic world. And this afternoon, showing the promising results of the carbon balance in coffee growing, we are paying attention to next steps, talking to international partners to have more and more recognition of our sustainability in the different markets and ensure the flow of a commerce without barriers, with good practices that we have here, and also evaluate financial movements in ESG, investments, green bonds, and derivatives, with examples, with investments in Brazilian coffee farming. This is our sustainability and social responsibility pillar. And so I'm going to turn to Silvia Pizol, that is going to coordinate this afternoon's work. Silvia, you have the floor. Thank you, Marcos. Good afternoon, everyone. I'm Silvia Pizol. I am Sustainability Manager for Secafé, and I thank you for joining us in this webinar. Today, we are going to talk about the results of the project Carbon Balance in Minas Gerais coffee growing with good farming practices, a project developed by Secafé under the technical scientific coordination of Professor Seri from the University of São Paulo, and Imaflora, here represented by Isabel and Renata. Next, we are going to have 3 presentations. I'm going to start talking about Secafé's objectives with the project, our engagement, how the exporting segment really took part of this project in Minas Gerais last year. Then Renata is going to talk about the technical aspects and the emissions of greenhouse gases. And Professor Seri will close the presentations talking about how we measured carbon sequestration in the soil, in plants, and also the results for the balance in Minas Gerais coffee farming. As you should realize, we are on webinar, so the mics are going to be kept mute. So if you have any questions, just write it on the chat box or on the Q&A button. In the end of the presentation, we are going to select some questions, we are going to read them, and we are going to answer them here live. We are also going to send all the presentations to the participants, and the webinar is going to be on our YouTube channel, both in Portuguese and in English. Very well then. So in context, how the project started. It started in July 21 with the Committee of Social Responsibility and Responsibility of Secafé, that was focusing on the international market trends. As Marcos mentioned, ESG aspects are gaining momentum as an influencer of movements and behaviors of consumers in the main markets for Brazilian coffee destinations. Consumers want different products. They have asked about the carbon footprint of products, and therefore we decided to go for this initiative to have an estimate of this balance of greenhouse gases in Minas Gerais coffee farming. The main objectives was really to evidence the state of the art in the production of coffee in Minas Gerais, contributing to scientific literature in greenhouse gases in coffee farming, with results that reflect the Minas Gerais production that happen at a tropical climate. It's very important that we add this information to literature, use the scientific data to have more transparency in the communication with international clients that have asked us a lot about the topic, show the relevance and foster adoption of good practices in coffee farming that generates resilience for climate changes and also open new and interesting markets, and use data to enhance the activities of promoting Brazilian coffee, which is key for Secafé, showing consumers that our coffee growing already has good practices focusing on sustainability. As I mentioned, just for us to have more credibility, And to be more impartial in the conduction of studies, we had this team of specialists from Imaflora, specialists in climates and emissions. They worked together with Professor Aldo Seri under his supervision. Professor Seri is a specialist of soil and climate change. And we also had relevant partners that made this study possible. Sequestration had the financial support of Lavazza Foundation, Starbucks, and also Educampus Sebrae, Minas Gerais, that was our partner in the region of Mata de Minas, and made available their technical teams to survey data in the region. And to talk about this project a bit more, although Renata and Professor Seri are going to give us a lot more detail, I would like to say that the objective of Sequestration was to have an average, an overview of the Minas Gerais coffee growing production. And for that, we had to divide the state so that we could have the main growing regions represented in this metric. So we developed the project in 40 coffee farms, reflecting the regional specificities and the production of each region. The farms were selected by exporters together with Sequestration and using technical criteria together with Imaflora team and Professor Seri. So we had 20 farms selected in the south of Minas, 10 semi-mechanized and 10 mechanized, 10 in Mata de Minas, all semi-mechanized, and the others all mechanized, reflecting the regions. And you can see that on this table, we see that we split the properties into the ones that adopted more traditional practices and those that adopt good practices, for us to see the impact of the adoption of good practices and the additional benefit in terms of carbon sequestration and emissions. And I'm talking about good practices, but what are they? In general, the main good practices selected were those that are aligned with low carbon agriculture. So what's the difference there? The use of organo-mineral fertilizers, organic compounds, and maintenance of soil coverage. And in the selection of properties, we also were very careful to follow some standard technical criteria that also made the comparison possible between traditional and good practices areas. The criteria were the density of plantation from 4,000 to 5,000 trees. And here we're talking about the Catuai variety, just to rule out any genetic variation. Age of plants, 10 years old, so before the first trimming, and from 2 to 3 meters. And the emissions inventory was calculated based on the data surveyed in farms, considering the trimming of trees, consumption, all following the methodology made available by the GHG protocol. And for carbon inventory, we had samples of soils in the regions and then sent them for the labs for analysis under Professor Seri. And as an additional piece of information that was not taken into account in GHG gases, we also calculated the carbon stored in the native vegetation that is kept in rural properties. That was calculated based on information available in the scientific literature. And for you to have an idea of conservation of nature in the 3 regions of the project, South, Cerrado, and Matas de Minas, considering all rural properties in which coffee is one of the plantations, we have 51.1 thousand square kilometers for native vegetation inside the farms, which is equivalent to 1.25 times the size of Switzerland. So it's very important to bring transparency to this environmental service provided by Brazilian coffee growers. And this was one of the objectives of Secapé when we asked for the stored carbon to be calculated. And here, just the field work. We had a carbon expedition in the state of Minas Gerais in the production regions between November the 16th and December the 3rd. The technical team of Professor Aldo Serres went through the regions collecting samples. So in the south of Minas, we had 2 pairs of farms, Mato de Minas, 1 pair, and Cerrado, 1 pair. And again, why pairs? Because remember, one traditional farming, the other good practices. The selection of the farms, we were very careful for them to represent the regional production system and also following the criteria that are established by IPCC in carbon storage, uniformity of soil texture, and others. So all the farms had to have a clay amount of about 35% to guarantee uniformity. And here I'm going to show you some images of the work that was developed inside the farms. Here you see we are collecting the soil samples. Here the collected samples. And here the trees that were also collected, and Professor Serres is going to give you more detail on that. But we extracted 3 flue plants, 9 altogether in the project. And as you can observe in the pictures, all the parts of the trees were separated: trunk, branches, the thicker root, the thinner root. We quantified the biomass of each of those parts, and then we sent it for laboratory to analyze carbon inventory. And then the final objective of the study is to estimate the carbon balance of coffee farming, thinking of the total amount of emissions of coffee production. Professor Serres is also going to explain the methodology in more detail.
So all scenarios which were analyzed led to a negative carbon balance. An important takeaway of this message is that traditional coffee growing already adopts advanced sustainable growing, which helps reduce climate change. And with adoption of additional good practices, in addition to those mentioned, carbon sequestration is even higher, leading to a even more negative balance. So it's safe to say that Brazil's agriculture is in the forefront of sustainability, all based on science and focused on continuous improvement. And that's, of course, eligible for green investments and to work and explore new opportunities in the carbon market. So on my end, this is what I had. I give the floor back over to Isabel, who will now be talking about Imaflora's work. And after that, Renata will detail the results of the emissions. Isabel, over to you. Thank you. Can you all hear me all right? I'll be very brief. I'll just have a word of thank you on behalf of Marina Piatto, our executive director, who is the founder of our area for climate and ambition. So a big thank you for your trust in our work. And just as Sylvia was saying, I'd like to emphasize the importance of having the will and also the support from all those partners for us to measure all that data and spread them around. The coffee industry has been in the forefront for a long time. We have always sought certifications, and we hope that we're able to inspire a whole range of coffee growers and also growers of other crops in Brazil. So thank you so much, and I wish you all a good, fruitful event. We're all looking forward to those results. Thank you. My turn now, right? Thank you, Sylvia. So I'll start by sharing my screen. Good afternoon, everyone. My name is Renata Potenza. I am the technical coordinator for climate and emissions at Imaflora. I also would like to thank Secafe for the partnership, for the chance to be here, for the chance to work together for the past few months, and also a big thank you to the technical committee with whom we had several positive, constructive discussions, and also a big thank you to Professor Adoseri, who's been with us all the time, and our technical team as well. Ana Luisa Vasconcelos, and others. All of them made this work possible. So as Sylvia has already mentioned, the idea here is to make a brief introduction about the methodology that we used, and then Adu will come on board and comment on the main results. So what we have developed for the past few months with Secafe was an approach to the balance of carbon and Brazilian coffee growing, looking at what we already have in terms of productive systems. So for farms using more traditional systems as a comparative basis, and also to look at the numbers at the farms where we already have advanced methodologies in place. So to get things started, I'd like to talk about Imaflora a little bit. Secafe's work is within our carbon on track. That's something we've been working on for many years, but now we have this program which aims at appreciating low carbon agriculture in Brazil. And we have our own communication system, which very, very soon in the coming weeks, we will be announcing. The idea, the intention is, in addition to bringing the technical ability to measure and monitor carbon emissions, which is also important, it's also our focus to communicate that in a more palatable manner. We know that technical terms are difficult to understand, those long reports. So the idea is also that we are able to communicate all those advances in a more understandable way. Things that have been done by Brazilian growers, institutions like Secafe, so that we can increase the credibility of those initiatives with the public. And with that, we'd like to take those concerns to other areas and perhaps influence other growers of other crops for them also to buy into good practice or better practices of measuring carbon that lead to environmental benefits. So moving to the technical front, as Sylvia mentioned, I talked also before, one of the focus is to look at that carbon balance, as I said. When we talk about carbon balance, there are two main variables which are part of that equation. Number one are the emissions. So we need to look at what activities happening now in the fields that entail greenhouse effect emissions, either CO2 equivalent. As you can see here, and Ada will be talking about this extensively, we're talking about all gases that have an impact on the atmosphere, and they are considered, therefore, greenhouse gases. We're talking about carbon, but methane, nitrous oxide. We tend to generalize and talk about gases as a whole, not only carbon. And we started to identify the sources for those gases, for those emissions within the farm or at the farm level. And I'll show you the breakdown of each of those gas sources and their respective estimates. A second phase, and Ado will be detailing in a moment, that's when we went out to the field to measure, is the carbon sequestration. And when we talk about carbon sequestration, we have two main reservoirs which are looked at. Is the carbon, in this case, at the coffee plant, and the carbon stocked at the soil level, which comes from those good practices. And a last bit of information to try and get everybody on the same page. You will see that we'll be talking about negative balance or negative numbers. And what do they mean, those negative numbers? A negative balance means that we are sequestering more than emitting those greenhouse gases into the atmosphere. So the negative or the minus sign shows that there's a higher sequestration, but in terms of concept, it is a positive result. In other words, it is a positive, it is a good impact when you see a negative number for sequestration. So for us to get started, as Sylvia said, I'd like to reinforce the two main results that we achieved, or the two main comments or final comments that we have in relation to what we have estimated for this project. So the first result is right there. Out of the 40 farms that were assessed, that were studied across 3 different coffee growing regions in the south of Minas, and we considered farms where they had conventional growing and those who had mechanical systems, semi-mechanical systems or non-mechanical systems with and without irrigation. So looking at all those different profiles and calculating that balance, we got to the final conclusion. Those farms, they present a negative carbon balance. In other words, they are sequestering more carbon, they are emitting carbon. And that's a very positive result for us to move ahead with our plan. And I'm talking even including those traditional farms with traditional methods of growing. And we know, as it was said, that coffee is a very advanced crop in Brazil. So even when we talk about traditional coffee growing, we already have reached a negative level of carbon balance. But when we look at the adoption of those good practices, the level of adoption, so when we have farms that further foster those good practices, the result is even better. It's even more positive, quote unquote. We have an even higher level of carbon sequestration, both at the soil level and at the plant level. And that negative carbon will be even higher in those farms. So we are removing even more carbon from the atmosphere than we are emitting. So we are surely contributing to bringing down greenhouse effect emissions. So those are the main comments we have to make, which are overall comments, and we'll go into detail on the next slides. So the first variable that I mentioned, which are related to emissions which were estimated for those 40 farms. So on average, the farms have an emission level of 1.74 tons of CO2 per hectare, or CO2 equivalent. Where is that number coming from? Nitrogen-based fertilizers are the main contributors, the main source. The use of those fertilizers out in the field make up the main source for greenhouse gases for coffee. That's nothing new for us. Other studies have shown the same result. Nitrogen-based fertilizers are the main villain here, followed by lime coming with 20%, and then liquid fuels. I'm talking about the fuels used by agricultural machinery, diesel or other types of fuel, especially for those highly mechanical farms. And then we have 8% coming from pesticides and herbicides and crop protection agents. Then the dryer. In several farms, the coffee is dried out in the field, but in some farms, we do have mechanical drying systems, or the burning of residue, or the burning of wood, or, as I said, electrical dryers. And then electrical energy at 1%, the lowest contributor. So when we transform those numbers into yield, talking about yield now, we have the farms assessed in Minas. They emit less than a ton per ton of green coffee, considering that an average yield for that farm was close to 35 bags per hectare, 34.6 bags per hectare. So those are the results from emissions that will make up the final result for the balance, which will be detailed by Ado in a moment. And the main takeaways are here on screen. I have mentioned nitrogen-based fertilizers are the main source of greenhouse gases. And then the use of lime also has a drastic contribution, and the use of good practices in coffee growing Brazil is at an advanced level, as I said. But when we implement them even further at a more intense level, or when we add other practices, we have further benefits, and this will be Ado's turn in this presentation. Thank you, everyone.
Thank you, Renata. Thanks, Secafé, for the opportunity, Maflora, to take part in this webinar. It is a pleasure. And I would like to carry on with the presentation. Before, I would just like to ask you if you can see the full screen. Okay, great. So Renata explained it well, and so did Sylvia, about the general context. Because, you know, whenever you have a balance, you have inputs and outputs. And Renata was talking about the outputs, the emissions that go from the soil to the atmosphere. Now I would like to go to the other part of the equation, the removals or carbon sequestration. And for that, we analyze the amount of carbon that is in the soil and in the plant. And you very well know that the CO2 that is in the atmosphere via photosynthesis can be absorbed by the plants. The carbon that was a gas goes and turns into vegetable tissues, a biochemical compound in the plant, and part of what is in the plant goes to the soil. So we have carbon in the atmosphere, in the plant, and in the soil. And I'd like to show you how we did that. Let's start with the soil. As Sylvia mentioned, we conducted the work of opening at the identified properties that had contrasting climate characteristics with different soils, but that are representative of the three main regions of coffee growing in the state of Minas Gerais, because this is what the survey was all about, the regions of south of Minas, Cerrado, and Matas de Minas. So how did we do that? First, we started to analyze carbon stocks. So I don't know if you are acquainted with that, but it's something simple that I show on the screen. Carbon stock is the carbon content multiplied by the soil density multiplied by a certain layer. So for us to follow international protocols that want to know carbon stock, we had to attain those samples in the field, and that's what we did. We established a sampling model, a template, and you see here, you have a trench, a hole that we open in the soil, 1 meter wide, 1 meter long, and we start to capture samples every 10 centimeters. I think Silva showed some images, but I'm showing some to you here. So you see this instrument that you see is a soil sampler for us to remove the intact samples, for us to calculate the soil density and therefore carbon stocks. So we open the holes for us to have the samples, and then also some distorted samples for us to analyze carbon stocks. And you know that the soil has variability. So instead of only trenches, we also had this other way of sampling the soil. If you don't know how we did, we use this drill to go into the soil and capture distorted samples at different layers for us to have a higher number of repetition in each of the regions that were sampled. Again, Cerrado, south of Minas, and Matas de Minas. So the takeaway here is that there are international protocols that require a series of procedures for the identification and collection of samples by drilling or by opening the trenches. And all these samples have to be prepared. And there are other procedures to be followed based on the IPCC, on ISO 14,000. So we have to analyze and prepare the samples. And the analysis is by means of a piece of equipment that is called elementary analyzer, which has the most precise, exact method for the analysis of samples and for the calculation of carbon content. So we have the density, we have the content, and with that we can calculate the carbon stock. So in a nutshell, that's the methodology used for us to get to our results. And for each of the areas assessed, we have the carbon distribution at the different layers. What you see in red are traditional coffee farms, and the ones in blue are those that follow the best practices in terms of coffee growing, as my colleagues already mentioned. And if you take a look at this chart, again, we have the different layers that were assessed up to 1 meter deep. And we have generally the concentration information at layers 0, 10, 0, 30, and 0, 100. And the international protocols tell us that we have to go to 6 centimeters deep. And then we have a series of inferences based on the samples collected. You see that the bars in blue represent soils with good management practices, and they are higher than the red bars that are the traditional systems. It's worth mentioning that the red bars, that is traditional coffee growing, are already showing very high amounts. So it is a challenge to get to start with a high amount and then have even higher amounts detected to be comparable to situations that are already very well being taken care of in the field. I have to say that we have to have the data that was presented by Renata talk to the carbon stocks. So we put together a strategy that is also described in literature, which is to calculate the carbon accumulation rate. How do we do that? We get the carbon stocks at a good practice area. We subtract the stocks that were found in a traditional coffee area. Then we are going to have a carbon delta, a carbon variation. We are going to divide this carbon delta by the time of adoption of good management practices. And with that, we can know the rate of carbon accumulation of a certain area in a certain period of time. So these rates are very important because they give us the possibility of comparing different areas, as Renata mentioned to us. Here is for layers 0, 10, 0, 30, and 0, 100. And we are using 0, 100, which is the best way to assess the areas. So for the several areas, we have an average, a mean rate of 1.7 megagram, which is a ton. But megagram is the international system, and we wanted to use the protocol. Carbon tons per hectare per year. it is possible for data to be comparable, as Renata mentioned. Renata showed that gas emissions are CO2 equivalent, that is, equivalent in CO2. In this unit, we include emissions not only from carbon dioxide, but methane, nitrate oxide. So the main GHG gases in this area, agriculture, capital raising, and others. And so I'm turning that into CO2 equivalent tons. So we have to multiply by 366, which are the molecular masses of carbon and CO2. And then you transform that accumulation of carbon in the soil to a mean CO2 equivalent rate. Now you have to help me remember this amount, 6.29, because we are going to use it soon. But before that, we have the plant itself. So we had a similar procedure that we did for the soil with the trees to quantify carbon that's accumulated in coffee trees with a similar methodology. We have to know the carbon stock within the plant. And for that, we had a giant work of removing trees from the field, of course, with the understanding and authorization of coffee growers. We know that that was a request that is difficult for them, but they were very kind and agreed, so that in each component of the plant, that is, the trunk, the branches, the leaves, the root, the material that is a remainder of the plant and that lays on the soil, everything was sampled, was weighed, and taken to the laboratory for, once again, use the analyzer I showed you before, the elementary analyzer that will determine the carbon content in each of the parts of the plant. And this image that you see here, I'm not going to go into detail, but I would like you to know that for each plant, for each component, we have a measurement. The roots, how much do we have carbon in the thin root, in the thick root, in the trunk, in the branches, in the leaves, in the remainders of the plant that lay on top of the soil. And so we compared, as we did with the soil, plants that were in good management practice areas and others that were in traditional growing areas. Once again, we should highlight that traditional practices are already promoters of considerable carbon accumulation. So it is a challenge to try to find more carbon to be accumulated in a good practice system. So the amount of carbon of one tree minus the other gives you the carbon data divided by the time of adoption, and this is about 10 years. And Sylvia said that, we talked about trees up to 10 years old, and then we have the carbon accumulation rate. And we did that for the several parts of the trees, and then we get a mean rate of 1.6 tons of carbon per hectare per year. And that I also have to convert to CO2 equivalent. That gives us a mean rate of 5.96 of carbon stored in the plant. So we have the soil carbon, we have the plant carbon, so we have to use the information. So here you have a summary of all the parts that were assessed. On your left, you have the traditional growing practices, and on the right, good practices. So you see, it is incentive, it is motivation for good practices to be more and more adopted, because you see we have more carbon in the soil and in the plant. And then you put all the information together. those emissions that Renata showed us and the carbon sequestration that we should consider when we're talking about a carbon balance. So first, I'm going to show you the carbon balance for traditional practices, again, that are already at a very high level in terms of carbon accumulation. And then going back to the equation that Renata and Silva mentioned, it is inputs and outputs. In terms of gas emissions, Renata showed emissions associated within the farms under the perspective of sources like lime, fuels, and others, and the sequestration that in literature gives us the number of 3.4 tons of carbon, with then a result of a negative balance of 1.6. And as Renato mentioned, negative in this case is good. It means that we are removing more than issuing or emitting, I'm sorry. That is what we have in the plants, the inputs are higher than the outputs. And this is what a carbon balance is all about in traditional farming. Even more interesting is to talk about good management practices that give us better results, which are so desirable in international negotiations. And then I'm going to show you the carbon balance, talking about good practices in agriculture.
Emission amounts, you have here the difference between traditional practices and a more preserve-based methodology, and the sequestration level at the soil level and at the plant level. And I ask you to make a note of those numbers. I'm sure you did. And the numbers now at the plant and soil level, as I show you, when you add that all together, you have 12 tons of CO2 equivalent, 12.25 to be precise. When we subtract from those emissions, we have a final balance, which is quite favorable, much more negative, in other words, even better than that accomplished with traditional practices. So this is an added stimulus for good management practice to be adopted. And as a consequence of that, we have a more beneficial, more interesting carbon balance. I'd like to say also that all those practices tend to be more profitable, lead to more yields. And as a consequence, we also have a good number for carbon balance as well. Another way to look at those numbers is to base our calculations not on tons of CO2 equivalent, but in terms of yields. That gives us a good metric in terms of footprint for that balance. And what you can see here in this CO2 equivalent units, once again, including all the gases, when we divide that by the average yield for those 40 farms, which is 34.6 bags per hectare, you see that the balance is also negative in terms of tons of CO2 equivalent per ton of coffee grown or harvested. So something close to 4, negative 4. Once again, negative is good. Minus 3.79 tons of CO2 equivalent per ton of green coffee a year. And to close my presentation, Silva has already said that we also measure areas that have preserved areas in the farms. The fact that we still have native forest in those areas, that translates as more carbon. That carbon is not being added to that balance, but that number should be recognized, and we should recognize the important role played by those areas in terms of capturing carbon. That may be not the case for other countries as it is in Brazil. So for the 40 farms, some larger, some smaller, and they, of course, sequester higher or lower levels of carbon. But the final takeaway is right here. 50 tons of carbon are now being stocked in the form of native vegetation for each hectare of coffee grown in those areas, which we have analyzed in the south of Minas and the Cerrado and other areas. That breakdown of that amount of carbon accumulated in our vegetation is now 65 in permanent preservation areas and 65 in legal reserves. That should be also be acknowledged. Some final remarks, some final takeaways. When we consider the carbon in the biomass of the plant and the carbon at the soil level, we see that the adoption of good management practices can bring about a negative balance. In other words, a beneficial balance of 10.5 tons of CO2 equivalent per hectare per year. Traditional methodologies are also negative, but it could be even more negative when we adopt better management practices. So the carbon brought in by those two practices can also be expressed or translated into coffee harvested, 3.79 in this case, per ton of coffee harvested. And we also need to take into account the role played by the protected areas in accumulating carbon. That's also an important service rendered by the ecosystem as a whole, by those 40 farms. So the idea here was not to compare different regions, but to divide the different actions across different farms so that the coverage was large enough. And the idea was to bring all those numbers in a consolidated basis as we did across all those coffee growing areas in Minas Gerais. Thank you all for your attention. We now remain available for questions that you may have. Thank you very much once again. Well, thank you. Brilliant presentation. We do have several questions, Professor. We'll try to answer at least some of them. Number one from Cássio Moreira. He wants to know if other fertilizers, phosphorus and potassium, are they included or not? Are they used in low levels? Hi, Cássio, good afternoon. They are not part of the calculation P and K. They're not considered gases or greenhouse gases by IPCC. That's why our focus was on carbon and nitrogen related emissions. And there are also other gases, fluorides and others, but for agribusinesses, we focus on carbon or nitrogen-based sources. Okay, Renata and Professor, we have a few questions about the carbon stocked at native preservation land. They were not included in the balance. They were calculated separately. So if you could elaborate on that a little bit, please. I can start and then Renata will jump in. The balance is based on agricultural crop. When you compare pasture land with well-managed land, a coffee land using traditional methods, when compared to a coffee area where you have advanced management practices. The idea is the difference in carbon sequestration can be achieved in those different systems. The native land are now in a dynamic balance. What's going in is also coming out, is what is called in English steady state. One side offsets the other side of the equation. That's not a crop area, a farming area. We cannot include that in our balance because the balance only takes into account farming areas. We could use other mechanisms, perhaps. There are markets for carbon credits, Ready Plus, for example, where for 1 ton of CO2 equivalent, which when it's accumulated in a forest, those amounts, each credit is traded at $5 US. Not the case here. We are only taking into account farmland because the native vegetation is now in what I call a steady state. Thank you, Professor. Anything else to add? Can I move on to the next question? No, nothing to comment, nothing to add. Thank you. Next question from Gustavo Barchi. He wants to know when in the year those soil samples were collected. And they say there might be changes because of photosynthesis effects, different variations, depending on the time of the year where the samples were collected. It's all true, but it does not affect our study. We're analyzing a 10-year period of carbon stocking. It doesn't really matter whether I collected the samples in 1 month or another. I'm talking about the year-to-date 10-year period. You are right when you say that we should be careful when we collect samples after the rainy period. That's one thing, I agree. Or when we have a wet scenario or wet plants, because if we did that, we'd have to do the same across the board. We would need to take into account different management practices in different sample collections. You are correct, but what we're talking about here is the following. We're not doing a one-off study. We are consolidating all those factors across 10 years of plant life. Heitor is a diplomat at the International Coffee Organization. He also sent some questions. Thank you for being here, Heitor. Brazilian agriculture is accused to foster greenhouse emissions with cattle raising, deforestation, and so on and so forth. First question, is the method used in your study internationally recognized, or will it be questioned by NGOs or other international institutions, universities? Because we fail to include other factors in the method. I can start, and then Renata can complement. All the methods used are recognized both domestically and abroad. We were careful with the process from the collection of samples all the way to the analysis and interpretation of results. It's all standardized. The GHG protocol is, of course, internationally recognized. What happens is that studies vary because of their different scopes. Some studies aim at the whole chain across the board, end to end. Other studies are focused on components of the chain. Our objective was to analyze at the farm level. And that's the information which is most sought after today, because most emissions are important because they're measured at the local level. At the industry level, that information is much more easily obtained. When you have an industry in place, that's easier. So the objective of our work was to focus our assessments at the farm level, because that's a more difficult environment for us to capture data. And as it was said, Brazil is heavily criticized. Some criticism not well grounded, as I see it, and those criticisms oftentimes come from countries which are developed, but that forget that 73% of all greenhouse gases in the world come from fossil fuel burning for energy in those countries. So I think we should, of course, have similar responsibilities, but we would like to see other nations making higher or stronger efforts to reduce emissions from the main villain, which is fossil fuels. Of course, we need to reduce emissions and we need to increase fixation, but a big effort is being made in agriculture in Brazil. And I don't see the same thing happening in other sectors that globally emit much more than we do. Thank you. I'll move to our Q&A. You can go back to the chat later. Two questions that talk about the same topic, one from Fernando Lopez. If the carbon delta was obtained by comparing traditional and advanced practices, how did you assess, how did you define traditional practices? And how did you calculate sequestration for the traditional system? I can start, Adu. Yes. And then Adu can come and help me. But for the traditional systems of coffee growing, we did not use values for removal at the soil level because the soil needs to compare different land uses, what used to be done before, what is done now. So that's why for traditional coffee, we only factored in the stock at the plant level. And that is done according to the cycle. We model the growth cycle for the plant, and then we annualize it so that we can infer how much. For example, it'll depend on the cycle, 20, 25 years of cycle, it'll depend on the grower. But now we can define how much that plant can sequester throughout that cycle.
I think that perhaps Renata has said it all, but anyway, there are two approaches, and I don't know if our colleagues are aware of that. One is the balance of the traditional system. That is already an accumulator of carbon. In this system, what we calculated, as Renata mentioned, is the carbon inside the plant. And that has a permanence of 3 decades. And this is calculated. And then the difference between emissions and the stock in the plant were following the models in literature. But even more interesting than that, in my perspective, is not the carbon balance in the traditional system, which is negative, but it can be even more negative. And I think that is much in tune with international negotiations, which is the term additionality. I don't want to make a very long answer, but I really get excited about that, as you can see. In the last international meeting that I took part, which was in a pre-COP in Copenhagen, people are talking about additionality. That is, what else, what additions can we have to the traditional farming to further increase carbon sequestration, reduce the carbon footprint, and improve the carbon balance. And I think that is the most beautiful part of this study, based on Secafé's initiative with the participation of Imaflora and myself, which is really surveying data in traditional growing and good practices growing. And so we have an additional benefit. It's not only what Renata said, but what can be sequestered in the plant and the carbon that is transferred to the soil. So I'm sure that more and more you're going to hear the term additionality, baseline, permanence, So these assessments follow all the most recent international guidelines. Thank you very much. We have two questions from Marcus Rocha. He's asking if the areas have any irrigated area and if nitrous oxide has been estimated. Yes, we do have irrigated areas. I think Silva showed the table. I don't know how many, but we do. We have farms that were irrigated farms, and the nitrous oxide is calculated. It is the CO2 equivalent I talked about, and so did Professor Seri. This is the transformation. Methane, everything that is turned into CO2. So it does go into the calculation, yes. And the Cerrado, as was mentioned in the beginning, we had, discussion of really choosing the systems that were more representative of each region. And in Cerrado, we have irrigated lands. So, if I talk too much, just, mute my mic. But this question about the nitro oxide is very important. Perhaps some colleagues won't remember, but each gas has a typical molecule and a level of interaction with infrared rays that leave the atmosphere and go up. So the gases interact. In short, each gas has a global warming potential of warming Earth. And CO2, based on the international panel, the CO2 has one, and all the other gases are comparable. Methane is 28 more times more potent than CO2, and nitrous oxide is 265 times more potent in global warming than CO2. What does it mean? I would need 265 molecules of CO2 to have one molecule of nitrous oxide. So it's a very important question. Small reductions in the emission of gas in the balance make a huge difference. And that, again, opens several windows of opportunity for management practices to adopt systems that can emit less nitrous oxide to the atmosphere. With nitrogen fertilizers, better sources, organic and inorganic sources. So all these things can be very interesting and give us, as I mentioned, a window of opportunity. So minor reductions can have a huge impact because N2O has a very, very high warming potential. Thank Professor. Our webinar is going to close at 5:15. We won't have time for all the questions. We are going to take perhaps one or two more, but Lauana Silva from the Federal University of Viçosa, how the utilization of organomineral fertilizers and organic compounds influences the emissions compared to synthetic fertilizers. Well, basically, in our estimates, the emission factors, which, as Professor Seri well explained, we have to think how much urea and other nitrogen fertilizers, how much do they emit? What is the factor we use to get to those numbers? And the impact is exactly that. When we are talking about organic compounds, have much lower emission factors. So when you replace urea or nitrogen fertilizer by organic fertilizer, you reduce GHG gases because they have a lower potential of warming than synthetic, chemical, more traditional fertilizers. Great, Renata, thank you so much. One more question. In the carbon bonus program, why don't we consider all the elements? Can I try to answer? It's not that you take one into consideration and the other you don't. It depends on what you are thinking. When you think of phosphate fertilizer, potassium, they don't emit GHG. They are not GHG gases. So when we are talking about these emissions, you're talking about indirect emissions. That is, when the fertilizer is produced, then you have temperature, pressure, you have the manufacturing process, and then you have the burning of fuel fossils. That is okay, but in the field, when you use the fertilizers, you don't have that. So today there are some norms, some scopes, 1, 2, 3, to try to compare things. But there are different objectives and different elements. Renata was saying the difference between nitrogen fertilizer that is organic or inorganic. If it is organic, it is not calculated because, it is a closed cycle, differently from urea, for instance. The CO2 emitted during the process is from a fossil origin. So all that has to be taken into consideration. But basically, these potential phosphorus, they do not have the gas. Thank you, Professor Seri. It's just 5:16. I'm just going to ask a final question, and perhaps it's not clear. Some people are asking you to tell us what were the good practices considered and what was their impact. Renata? I can start. So the good practices that were considered were, as we mentioned, there are some good practices that can be implemented on the field. I'm going to mention 2 or 3, and then Professor Seri can mention their impact. But it is what we are talking about. The use of organic mineral compounds, so the replacement of nitrogenous fertilizers with compounds that are that emit less gases, keeping the coverage of the soil interlines. Professor Seri can talk about that, how that helps with carbon sequestration in the soil. Let me try to remember. There are so many things. Lower use of chemicals, more efficient use of fossil fuels, less burning of wood or residues. So all these practices will have an impact when we are talking about the reduction of emissions and also carbon sequestration. Ado? Well, Renata, I think you said it all. We talked about fertilizer fuels. I'll just give you an example, which is the vegetable coverage between coffee growing lines. If the soil is bare, if there is no coverage, solar rays will heat the soil. We are going to have more oxidation, and we are going to have less sequestration of carbon. the carbon goes to the atmosphere. And also, if the soil is uncovered, we have more erosion. That is also something that the coverage of the soil protects against. So water, biodiversity, and focusing on our talk here, these areas, these vegetable areas between coffee lines, they really contribute with carbon. And why? Because you have a recycling of plants. When a root of a plant dies, a part of the carbon is kept in the soil. When the root is alive, you also have carbon in the system, and you have the aerial part of these plants that help with the coverage. So you are constantly adding carbon to the system and accumulating more carbon in the soil. So there are several benefits. I just said one, otherwise we are going to go way above our time. Thank you, Professor Sari, Renata, everyone for attending. Unfortunately, we are not going to be able to answer all the questions, but now I'm going to turn to Marcos for his final words. Marcos? Good afternoon, everyone. I'm very happy with this presentation, promising results for our coffee growing, for coffee business in Brazil. I'm happy for your time, Professor Sari, Maflora, Flavia, Silva, you all that are following us. We have the commitment, which is to present the results in international fora. We are already evaluating the best times together with our partners, and we are always continue supporting coffee growers and our product. You can count always on Secafe, and thank you very much. Goodbye, everyone. Bye-bye. See you next time.